Block and a tackle has two pulley in each block, with the tackle tied to the hook. Tackle tied to the hook of the lower block and the effort being applied upward. You see, basically there is a tackle here. It has got two pulleys, one here, another tackle here. It also has got two pulleys, right? But the load has to be two pulley in each block. The two blocks I have drawn that, and the tackle tied to the hook, with the tackle tied to the hook. So this is tied to the hook here. Okay, this is tied to the hook, and obviously it is tied here. A block and tackle of two pulleys in each block, with the tackle tied to the hook of the lower block. Okay, lower block, and the effort being applied upward. Okay, this is the load over here. This is the load over here. This is the load. Fine. So, and it has to be pulled upward. Fine. So how it has to be done here? See, first of all, you have to make it like this. Okay, this will go like this. It will come here, and it will go like this, and it will come here, and then it has to be lifted like this. Fine. So this is how it should work. This is the drawing. Okay, I have drawn it roughly. You will have to draw it in a proper manner. So see, draw the knee diagram. The block 2 tackle 2 pulleys. Okay, we have got 2 pulleys here, another 2 pulley set here, and the tackle tied to the hook of the lower. Okay, the block of okay, with the tackle tied to the hook of the lower block, and effort being applied upward here. Is that okay? Now if you say to make it okay, rough diagram I have drawn to make it a proper one. I'll just put a figure which is already there in it, and I'll explain with that. Okay, so this is the figure that we have here. Okay. So you can see we have got here the load at this point. Actually, you have to draw it in this manner properly, right? This is being okay. You can string that is going this way, coming back. First one, then first one, then second one, then second one, like that. Okay. How many T's are there? One T upward, another T upward, another T upward, another T upward, another T upward here. Is that okay? And load is where? This is the load that we have here. So how to calculate the mechanical advantage? Mechanical advantage is what? Simply load by effort. So how many T's are there? You can see 1, 2, 3, 4, right? And even the fifth one. How many T's are there? 5. All right. So we can write here load is how many T's? 5T. And you can see the effort here is just 1T. Right? All right. If I just remove all of these, you can see it here. So what do we have? 1, 2, 3, 4, 5T, and effort will be just, you can see it is directly putting the load here, right? So this is just 1T. T and T got cancelled, so mechanical advantage is 5. and this is the answer for the question that we have in A. If the load moves up by x, what distance will the free end of the string move? If this load goes up by x meter, then how much will this end move? That's a question, right? So see, if you move it 1 meter, just imagine if you move it 1 meter, then what will happen? This will move, then further this will move. Okay, here you getting it? This will move. So basically, if you move it x meter, right, the free end here will move. Okay, if the load moves x meter, then this has to move 5x meter, 5 times x meter here. Is that okay? Because there is a 5t over there, right? So we can say write the answer for the second one. If load moves up a distance of x, then the free end of the string will move by 5x times 5x meter. See, if you move it 5 times, then only it will move on it. As simple as that. Mechanical advantage is 5 also in it, right? You can take it in that manner. But yes, this is the answer for the next question that we have done. And there are only 2 questions in it. So we do, one was to draw it, another one was to draw it, another one was to write the answer for this calculation of MA, and the other one here, right? So fine, we have done that.